AI is about to get a whole lot smarter, and Google DeepMind's latest breakthrough is proof. They've developed a new method called SCORE that teaches AI models to correct their own mistakes without needing human help. All right, let's start with the problem that needs solving. When LLMs make errors, they often lack the mechanisms to realize their own mistakes and revise them in a meaningful way. Think of how often you debug a piece of code or double-check your math to catch a small error. Current AI models don't have that reflex unless you explicitly guide them. Even though they know the necessary steps to solve something complicated, they are not great at applying that knowledge dynamically. This becomes especially problematic in multi-step tasks where one wrong step early on can cascade into a completely incorrect final result. The typical approaches to get around this involve prompt-based adjustments or multiple attempts, but they often don't work consistently, particularly when the model faces complex problems requiring several layers of reasoning. To address this, Google DeepMind has developed self-correction via reinforcement learning, or SCORE. It's a novel method that allows AI models to self-correct, learning from their own errors and improving over multiple attempts. What's innovative here is that it doesn't rely on supervised methods, which typically require lots of external data or another model to act as a verifier. Instead, SCORE teaches the model to correct its own mistakes through reinforcement learning using self-generated data. This shift is significant because it reduces dependency on external systems or human oversight, which is both computationally expensive and not always scalable. Before SCORE, LLMs often needed supervised fine-tuning, which involves training them to recognize and fix mistakes based on historical data. The problem with that approach is that it tends to amplify existing biases from the original training data set, causing models to make shallow or ineffective corrections. Another method, which involves running a second model to verify the output of the first, is simply too resource-intensive for most practical applications. Plus, when the data the model is trained on doesn't quite match real-world scenarios, things can fall apart quickly. SCORE breaks away from that by introducing a two-stage training process. In the first stage, the model is taught to generate meaningful corrections without getting stuck on minor edits that don't really change the outcome. It's crucial because, in many other approaches, AI models only tweak small parts of an answer instead of addressing the underlying issue. SCORE's first stage builds a robust correction strategy so that when the model identifies a problem in its response, it can make substantial changes instead of just glossing over it. Then comes the second stage, which uses multi-turn reinforcement learning. This phase rewards the model for making better corrections on each successive attempt. The idea is that with each pass, the model should learn to improve the accuracy of its response. By shaping the reward system correctly, Google DeepMind has made it so the model is rewarded for improving the overall accuracy rather than just making minimal changes. This leads to a much more efficient correction process. Let's get into some of the results because the numbers speak volumes. When applied to two specific LLMs, the Gemini 1.0 Pro and Gemini 1.5 Flash, SCORE led to impressive improvements. In mathematical reasoning tasks taken from the math data set, self-correction accuracy shot up by 15.6%. For coding tasks from the human evil dataset, accuracy improved by 9.1%. To put that in perspective, after the model's first attempt at solving a math problem, it had a 60% accuracy rate. But after running through the self-correction phase with SCORE, the model's accuracy improved to 64.4%, proving that it could revise its initial output more effectively. This improvement is especially significant because traditional models have a common failure mode. They might change a correct answer into an incorrect one on a second attempt. SCORE minimizes this by reducing the number of instances where correct answers are turned into wrong ones, while also boosting the instances where incorrect answers are corrected. For example, the correction rate for math problems went from 4.6% to 5.8%, meaning the model fixed more errors on its own and did so more effectively. But what makes SCORE especially promising is its ability to generalize across different domains, not just math but also programming. On the coding side, it achieved a 12.2% improvement in self-correction accuracy when tested on the human evil benchmark. This is a major advancement because LLMs are increasingly being used to generate code, which needs to be syntactically and logically correct to be useful in real-world development environments. The underlying methodology is worth unpacking a bit more. Traditional fine-tuning methods are problematic because they often rely on static data. For example, a model trained to fix its mistakes using supervised fine-tuning gets locked into the biases present in the training data. When it encounters something different in the real world, the mismatch between the training distribution and real-world input can cause major issues. SCORE bypasses this limitation by allowing the model to work with self-generated data through reinforcement learning. It adjusts its approach dynamically based on the mistakes it makes and rewards itself for getting better with each iteration. SCORE's two-stage process is crucial to achieving these results. During the initialization training, the model focuses on learning a correction strategy without collapsing into minor, inconsequential edits. The second stage of reinforcement learning then focuses on optimizing the model's self-correction in a multi-turn setting, where the model learns from its earlier responses to fine-tune its future attempts. The reward system is carefully shaped to ensure the model doesn't just make small tweaks, but instead aims for higher accuracy in subsequent corrections. Let's zoom in on the reinforcement learning aspect. The process involves something called reward shaping, where the model is guided towards making more meaningful changes instead of just adjusting small details. This is critical because one of the pitfalls of self-correction methods is that models tend to gravitate towards minimal edits that don't really improve the final outcome. Reward shaping nudges the model to aim higher, focusing on correcting the core problem instead of settling for superficial fixes. Another key point is that SCORE is not just improving the performance on the first attempt, but also ensuring that the model gets better on the second pass. In their tests, Google DeepMind found that the model's self-correction ability improved not just in accuracy, but also in how efficiently it corrected errors without making things worse. This was achieved by minimizing the number of correct responses that were mistakenly changed to incorrect ones during the second attempt, a common problem in other methods. The research also took a close look at the edit distance ratios, basically how much the model's second response differed from the first. They found that models trained with traditional methods tended to play it safe, making minor adjustments and sticking close to the initial answer. But with SCORE, the AI was more willing to make substantial edits when necessary, which is key to meaningful self-correction. This ability to make larger, more impactful changes without collapsing into minor edits is what sets SCORE apart from earlier methods. The broader implications of SCORE go beyond just improving self-correction. What Google DeepMind has essentially done is lay the groundwork for AI models that can independently improve their performance in real-world applications without needing constant oversight or retraining. This is especially valuable in fields like software development, where the ability to self-correct code generation could make AI much more reliable for developers. It could also have a huge impact in areas like automated scientific research, financial modeling, or even education, where models need to handle complex, multi-step reasoning tasks reliably. Looking ahead, one of the potential next steps for SCORE would be extending it to more than 2 rounds of correction, which could further enhance the model's ability to handle really tricky problems. Google DeepMind is also exploring ways to unify the 2 stages of training, which could streamline the process even more and make the model even more efficient. By training models to improve themselves through reinforcement learning on self-generated data, SCORE makes these systems more flexible, reliable, and ultimately more useful in practical applications. Essentially, the ability to learn from mistakes without human intervention is going to be a crucial factor in the future of AI. With these advancements, we're getting closer to AI that knows when and how to fix itself, making it more reliable across a range of domains. All right, if you're interested in more deep dives into AI, robotics, and the future of tech, make sure to like, subscribe, and leave a comment. Thanks for tuning in, and I'll